Hi, this is Khan, and I hope you can enjoy this beautiful. We have a lot of links now. We have populated it quite well, so that at least we can do some interference analysis. So I will show you in this video. Basically, we have made it. These links, they are made for educational purpose only, and there are some inherent issues that we know as well, because as you know that we have made these chains with a single frequency channel. So we know that when we have a same channel, then the channel should give some interference. So, but I will try to show you that how we iterate through these errors and how we try to solve these one by one. But just to let you know, or just to show you that, for example, these are links which are fully connected. I mean, we have made chains and we have populated these links. We have provided the frequencies to them, so that now we can try to do some frequency interference analysis, and we try to remove it. This video will be a bit longer because I will try to do it iteratively so that I can show you a few times. So let's start. Initially, we put it with some bigger values, and I will show you this. These are the initial values which are normally set, not exactly, but mostly it is like that. And we will try to run it on phase 3 with phase 3. So this chunk, we will try to do interference within this chunk first. Generally, if we are adding a chunk of sites to our existing network, first we should do the interference within the chunk itself, so that at least we know that there is no issue within that chunk in itself, and then we should do it with other links. So 62 cases are reported. Okay, and let's try to analyze. First, let's see if there is any high-low violation. There was no error because high-low violation is reported as well. So you can see that because we have put these frequencies through our tool, so we don't have any high-low violation. Now, if we want to see what is, because there was no error as well, so we will not go to the error files, and we can see the summary report. This is a report that generally we share with our customer, and it has, you can say that it has a lot of values. It has all the cases one by one. It's a 15-page report, and it's showing all the cases, like 62 cases are reported here. But for a normal analysis, this report is not very much useful, because in PathLoss we have some other good tools. This is just a report, you can say. Cross references also, I will not say that this is also a good report. In the cases, you will know that how much are the correlated and how much are the overhead. OH loss cases, I mean over the horizon loss. So correlated, it means that the link and the interfere, they are coming through a normal line of sight. And OH loss means that interferer is not in the exact line of sight, but it was coming from some distance, you can say. So generally, we take these as more significant, and we take the OH loss one as less significant, because the clutter around the area may be mitigating these by itself as well. They may not be affecting that much, which is shown here, kind of. So third report is the case detail. Here each case is separately mentioned. The victim is shown, the interfering TX is shown, and you are provided with a lot of other data, that what kind of antenna, what kind of radio and everything. So we can see that the interferer and the victim, they have the same channel number 5. So these are these were the reports, but generally this is not the tool to fight it. The main tool is this tool, browse interference cases. So the good thing of this tool is that, as you can see here, the tool shows you each and every case, and it shows you exactly where it is on the network diagram, so that you have some idea. Like for example, if you see here, these 2, 3, 4 cases are in very near vicinity. It means that if we are able to identify and we try to correct one, then maybe 2, 3 will be corrected at the same time. So we can see that now it's bringing some from very far as well. So I like this way, and we will start from the case 1, and we will try to correct the case 1 first. So you see here this side, that the TX on that side is hitting this one, because we are using the same frequency. And if we see the second, it is coming back to back, then again, and then it's hitting the other one. It means that if we just change the frequency of this middle one, we can get rid of maybe 6 cases. And let's try to do it, because we know that all of these have the same frequency. So what I will do right now, I will just change it. It's 5 high. Let me remove it. Let me make it 1 high for the time being. If you're doing a very good work, I mean, you should note all of your changes. You should note a lot of things, and then you should act up accordingly. Not like me. Like for example, I'm doing it in a kind of haphazard way. I mean, but we should not do it like that. Because sometimes what happens is, because if you don't write things, if you don't take notes, then we may be doing a same. I mean, for example, maybe we may be changing, or we may be going in a loop. I mean, we will be changing one frequency, it creates something somewhere else, we change that, it creates something back, and we change that, because we are not keeping a track. So whenever you are changing anything, just keep a track that okay, what you are changing, so that you don't go in any kind of loop. But as far as this video is concerned, I will just tell you the main things. I will not guide you, or I will not go in a very best way, because some things we leave it on the students as well, that they should also take the main crux of things, and they should use some of their own intellect, so that they can learn good. Okay. It is a very iterative way. It's a very iterative thing. You do something, and then you run, and then you do, and then you run interference, and then you do anything. So you have to go through it a lot of times. So it's not like that you do 4 or 5 things and then you check. It's not the best idea. It's not a good idea. The best idea is that make one change and analyze. Make one change and analyze. Otherwise, you will lose the track very fast. Okay, so sorry, it's my mistake. No, it's not my mistake. I calculated things. It's saying again 62. Okay, what happens? This one is back. Okay. So even though we have again 62, but the initial ones are gone. So we have now site 4 is hitting. Okay, let's now take this site 4. So it means that whatever we did here, we changed this frequency. It corrected 3, 4 links, but it introduced some problem in some other 3, 4 links. So we came back to where we were. So let's change it. This is channel 1 high. Let's make it okay. And then I will run it again. So I was not able to reduce. I increased from 62. It went to 63. So this I was trying to tell you that when we do it, then sometimes it may not be working as we are taking it. So what is the kind of solution, how we should go ahead? First thing is that let's because if I show you this report, This is quite a strict report because we have put a threshold degradation of 1. What we should do is that we should try to come from something very big. Like for example, let's try to find bigger issues first. Let's make it 20. So 15 cases which are even above 20 dB of threshold degradation. So it means they are hitting our network very high. So let's start with them. Let's try to remove those first. So if you see here, 403 is 402, which is receiving from 403, is being hit by 414, which is receiving from, which is transmitting to 413. So here we can see that they are having, it is coming almost directly because the length is same. Okay. Generally, if it's a hilly area, it may not hit that much far, but this is too much. So let's try to resolve this first. I can change this one. This is on channel 5. Let me take it to channel 2. Okay, site 2 is high. Okay, now let me run it again. Phase 3 with phase 3, calculate. We still have 13 cases, but let's see. So the first case is gone, but now 403 is being hit from the other side as well, from 424. 424 is this one. This is also in exactly the same path. So let's change it to channel 3 and then let's see. So okay, now we have 12 cases. Let's see the next one. So site 429 is hitting site 402. So this is also, you can say that quite in the same, almost the same, I mean, because it's a bit lower but it's a bit tilted as well, so it may be hitting it. The reverse side may not be hitting fully because reverse side is going towards here, but this side is almost hitting this. So we should change this 429. Let me check this. This is already on channel 4. So let me check this. This is on channel 5. Let me change it to channel 2 and let's run this interference again. So we increased another case. So we were not able to decrease the case, but we increased it. Okay, let's do one thing, like we get another case now. This is also so let me try to give you some idea from here of about some other aspects as well. One is that we will try to make, if we are trying to make a chain and the chain is exactly in the same path, if we are coming in the same path, then what we should do is that we should try to use different frequency channels in the chain so that we don't go in this kind of issue. And currently we are just changing the frequencies. We have 6 frequency channels, but what is happening is that whenever we change somewhere, it coincides with some other thing which is maybe already I changed it previously, so that's why it is not. Okay, this is channel 2 and this is also channel 2. Okay, let me change it to horizontal and let us rerun. Let us just check that you see, just changing it from vertical to horizontal, we have removed the case. Okay, let's go to the other case now. So this is 402 and coming from 424. Again we can see here what is the issue. It is again channel 2. Let's change this also to horizontal and let's see if this helps us and we are able to remove one more case or not. So we are back to 11 and okay, this is still hitting it. 402 and 414. 414 and 402, they are exactly in the same line. Okay, I made it horizontal, but still, okay, let me then change it to channel 3 and let me make it horizontal. Let us run it again. We are still with 11 cases. So the number of cases between those two sides are not going down. Why? I had changed it. This is channel 2 and this is channel 3. Okay, so it means that they are basically not showing a threshold degradation of 25 dB. Why? This is 7546 and 75 and those, so these are adjacent channels. Okay, let me try to make this boat more. I should not put 28 here. I should put 28 here, not 25. And then let me recalculate because it is calculating the adjacent channels as well. Or we can ignore adjacent channels from here. So we have still 11 cases. The case has not gone yet. Okay, I ask it to remove the adjacent channels. These are basically adjacent channels, but no problem if it is not able to remove it. Let us change it to channel 3 to channel 4 and make it horizontal and let's run it again. Sometimes path loss is a bit buggy kind of thing. So okay, so we reduced to 9 cases now, which is a good sign that something has worked. So now it's the same. No, it's the adjacent channel. Why it's bringing the adjacent channels? This I'm not sure. Interference, calculate, ignore adjacent channels, but it is not ignoring. I should keep it at 56. Okay, we still have 9 cases and it is still there. Okay, no problem. Let's try to resolve this. Let's see how much it is. This is channel 1. We make it horizontal and interference. Let's run it again. So we move back to 7 now, which is a good sign. So now it's again adjacent channel, site 420. Let me see. Let's first change it to horizontal and yes, we run interference again. Okay, phase 3. So we removed 2 more cases and where is it now? It is here. So 432 is okay. These two are again, these are quite okay, adjacent channels. Okay, if I change this one is what? This is channel 4 and this one is what? This is channel 5. Let me change this to channel 2 and let's run it again. So let's see what happens. So we removed one more case. We are left with 4 cases now. Where is this case? Okay, we have reached this area. 1, 2, 3, 4. Okay, so all cases are here. And this is same channel, this is same channel, same channel, same channel. Okay, I have to change 2 channels and it should go fine. And we have, okay, so site 436, 437, 438, 439, 433, 34. Okay, so this 434 and this 436 and 7 and then this 438 and 439. These are almost in the same Okay, let's try from the middle one. It's channel 5 low. Let me change it to channel 3, and I hope to remove a good number of issues now. Okay, so you see only two cases now remaining. These are because of this. Let me change it without even looking at this, and hopefully we should be seeing now no interference. We reach back to 4 cases. This happens. I take it to the third channel. I take it to channel 3. Let me change it to channel 2, and let's run it again. Basically, a lot of things has to be done. We are still in 4. Let me change this one. Take it to channel 6. As I told you, that this is the iterative thing, and if you are not keeping track of everything, then you may be running in a loop as well. So because I'm just doing it from my mind, so 2 cases is still reported. Let me see those. So this is the same channel, and this is again the same channel. Okay, 8612. So this 8612 is channel 5. Let me make it channel 1 because I have used channel 1 very less here. But as I told you that we are not doing it. I just try to. I'm just trying to do it in a normal or haphazard type of way. We are not taking any notes. We are not making any records. Okay. So still without using any notes or anything, at least we were able to remove all the higher level of cases. Just assume for a few minutes that, because generally what happens is that when we remove the high level cases, then we should bring it down to 10, and then we should run it again, and then we should see that okay, like 22 cases are still remaining which are higher than 10 dB. But I will not go behind those 22 cases, because the idea of telling you, or the learning is from my side, I will say that it's a kind of complete, that at least on some objective we reach to 0, and this is the objective of threshold degradation mitigation, or recovery. That what you do is that you keep changing the frequency channel, or the from vertical to horizontal. Vertical to horizontal we should not change a lot, because this needs a field activity. You have to send someone who has to go and who has to change the polarization of the link. But changing the frequency is because it's software based. You can change frequency from the NMS. So it's the first thing that we should do. And assuming that you completed everything and you made it to 0, then the next step is that then you need to check it from its surrounding. Like for example, I will keep it again on 20 because this was where we get a 0 case reported. So now what I will do is that I will take phase 3 and I will test it with phase 1 first. For example, I see okay, no cases reported. We get some error, but that's another thing. Then what we'll do is that we will check it from the other links as well. Phase 2, again we did not get any cases because the main channels are a bit different and they are a bit farther as well. But assuming that we get everything fine, then next step should be that we take some area. Like for example, if we see that in this area, for example, assume that these are too many sites together. So what then we will do is that we will run interference between these selections, and we will see that okay, how many cases are reported, and then we will try to correct these cases. So this is how we go about it. Is that I don't know why I got a lot of issues here. Generally, we should not get a lot of issues here, but these should be basically this should not be in enter these areas. These should be within the areas because we have not corrected. First we have to correct the links which are within a group, and then we should check these with the other group. So basically, the link within the group still have a lot of issues. Okay, you see some of this is coming from here to here as well. Assuming that we have corrected all these, then we will have to see that what is coming from here to here, and then we have to correct that as well. And correction of this will be more because when you will correct it, then this correction will bring some issues within this chunk and the other chunk both. So it is where it becomes more complex and more you can say that more difficult to manage, because now we are getting interference from very outside of the initial network. So assuming that you had 5,000 sites and you added 200 sites in some region, and first you check the interference within those new 200 sites, and you find that these are all fine. But when you check the interference between these new sites and the surrounding old sites, and then if you find any problem, then you know that changing a single frequency can bring a lot of changes on the both sides. So this is where you have to keep a lot of patience, and then you have to do this thing with a lot of documentation. You have to first try to make a list of the frequency which are being used and introduce a frequency which is not being used anywhere, so or at least in the vicinity, and then you should try to make this change and then try to run the interference analysis. But I hope that the idea should be easy or understandable to you now. You should understand that this all frequency interference mitigation is, number one, it's not a simple job. Number two is that it's an iterative job. It's not that you did something and it was fine. No, you change, and test, you change and test, and you change and test. So you do it maybe 100 times, and still something happens, or sometimes it happens that you tried everything, but you are not able to bring it down from some level. Then at that time you have to talk to your operator, that for example, if we are not having any very high threshold degradations, then at least if there are any degradations which are very low, like 3 dB or 4 dB or 5 dB, we should accept it. Also, there is one more thing. For example, assuming that you still get 4 cases which are 3 dB, 4 dB kind of cases, not very high cases, then path loss gives you this one option, is that update the path loss files. You can update the threshold degradation, or you can remove those threshold degradation as well. So what happens is that, for example, at this place, if I find that okay, I have tried everything and 4 of my links, they are still having some threshold degradation, then what I will do is that I will update this threshold degradation in the actual link files. So path loss will update those link files. For example, for a specific link, the threshold is degraded by 3 dB. So it will rewrite the new value of threshold on that link. And you know that the threshold has a direct connection with the link performance. So this will undoubtedly decrease the link performance. Then you have to go to the link and you have to check that okay, if that link was, for example, on 99.999, then after the addition or degradation of this 3 dB, where it has come, if it is still within 99.995 or 996, or it has very severely degraded to 99.9 only or whatever. So based on that, then you can make your final judgment. So what we generally do is that once we are final with our threshold degradation mitigation, I mean we have done whatever we can, then we update this threshold degradation to the link files, and we make generally a note of what links are being affected. We get a link report also. I mean we can see from the link reports, from this summary report we will have all the links. And then what we will do is that we will first update these files, then we will go to those specific links, and then we will, for example, let me try to show you some very high value links. Okay, like one case was between like 401 to 402, and then 402 to 403. This was just 0.79 dB, so it is not very high. Let's try to find some big number here. Like this is 9 dB. 403 to 404. So 403 to 404 is 9 dB down. So let's check 403 to 404. So we can see that the receiver threshold is minus 49, and we have a fade margin of 10 dB, and this is 99.95 on the highest one. Okay, so what we do is that we go to upload files, we edit this, and we go to this file again. So threshold is still 49. No, but you see this is 98.8 now. So threshold degradation is added somehow. It has changed this value to 98. Before it was 99, but it has not changed other things. Let us keep an eye on this. 403 to 404 is 98.8. Let me remove threshold degradation and let us go back. So you see this becomes better. It came back to 99.9. So we can see that the number is changing here. The performance reporting is changing. It's not changing the exact values because these values, it is not changing the values in this column, but it's changing the effect of these values. Like when we added threshold degradation, then we saw that the effect was shown here, that from 99.9 you went to 99.8. So for example, if you want to use it mostly in the 64 QAM, which is 99.999, let's just go back again. Let's do it one more time just to make you sure. So 464 QAM. So from 5.9 we are still on 4.9. It's 99.99. So now this decision is up to you. This is not bad. Because generally we plan the link for something in the middle. So in the middle we have 99.99 still. After 10 dBs of threshold degradation, we are still with 4 nines. So let me remove that one more time, and let me go back here, and then we see that this is again back to 5 nines, 99.999. So this was what I wanted to tell you, that okay, first we have to remove all possible frequency interference, and once we are sure that we have removed all possible frequency interference, then what we can do is that we can transfer the values to the links, and the performance of the links will degrade based on the threshold degradation. And then we have to see that okay, can we afford this much degradation? This link from 99.999 it went to 99.29 only. So if it is acceptable, then we can kind of live with that. But if we have a lot of frequency channels and we can very easily change from one channel to the other channel, then it is better to remove your interference as much as you can. So I hope that this a bit longer session should be beneficial for you. You should have learned something from it. So let's meet it in something good, and I hope that this thing is well understood now. But if you still have any question, because it's not very easy and simple task, so if you have any question, you can comment or you can contact me, and then we can maybe see if you are going through some interference issue, then we can try to mitigate that. So till then, let's meet in the next video. Goodbye.